All right, let's dive into one of the biggest, most mind-bending ideas out there, time travel. Is it just something for the movies, or could it actually be a real physical possibility? We're going to break it all down.
So, let's kick things off with this wild idea from the guy who literally rewrote our understanding of the universe, Albert Einstein. He's suggesting that our whole experience of time, one moment flowing into the next, it might just be in our heads, an illusion.
And that right there is the big question, isn't it? If time isn't some unbreakable law of the universe, but more like a suggestion, well, can we find a way to bend the rules? This is where we start to separate what might actually be possible from pure science fiction.
To even get our heads around traveling in time, we first have to figure out what time is according to the physicists who study this stuff day in and day out. And yeah, that means we have to talk physics.
Okay, so for centuries, everybody thought of time the Newtonian way. It was simple, a giant cosmic clock just ticking away at the exact same rate for everyone, everywhere, absolute. But then Einstein comes along and just blows that whole idea up. He showed us that time isn't its own thing. It's woven together with space into this four-dimensional fabric he called space-time. And here's the kicker. That fabric can be bent, stretched, and warped.
And because space-time is flexible, something absolutely incredible becomes possible. So let's get to the really cool part. Traveling into the future? It's not just a theory. It's a proven, measurable fact of our universe.
So here's the key takeaway from Einstein's relativity. The faster you rocket through space, the slower you actually move through time compared to someone standing still. It's an effect called time dilation, and it's not just a feeling, it's real. Your watch would literally tick slower.
And this isn't some abstract math problem, We can actually see it happening. Just look at the astronauts zooming around the Earth on the International Space Station. They're moving at a mind-boggling 28,000 kilometers an hour. And over a typical 6-month mission, that speed has a very real effect on how they experience time.
After those 6 months in orbit, an astronaut has aged just a tiny bit less than all of us back down here on the ground. They have effectively jumped about 5 milliseconds into the future. Okay, it's not a lot, but it is a real one-way trip, and it's proof positive that future time travel is possible.
So, a one-way ticket to the future? Yep, it's on the table. But what about the Holy Grail? The thing we see in all the stories? Going back to see the dinosaurs, or fixing a mistake? Well, this is where things get a lot weirder.
Now, physicists have dreamed up some truly brilliant, though, let's be clear, super speculative what-if scenarios. We're not talking about a DeLorean here. Think more along the lines of fundamentally warping space-time itself, maybe using something called a closed time-like curve, an Alcubierre warp drive, or even theoretical shortcuts through space and time called wormholes. But here is the massive, and I mean massive catch. While these ideas look great on a blackboard, actually building one is a whole different story. I mean, to create a stable wormhole, you might need something called negative energy, which is a type of matter we're not even sure exists. So for now, these are way beyond our reach.
But okay, let's just pretend for a second. Let's say we could solve the energy problem and build a time machine. We'd immediately slam into a totally different kind of wall, the paradox problem.
We're talking about breaking causality. The basic rule that a cause has to come before its effect. And one of the most brain-twisting examples of this is something called a causal loop, or the bootstrap paradox. This is the idea that an object or a piece of information could get stuck in a time loop, meaning it basically has no origin at all. It just is.
To really get this, let's walk through this classic thought experiment. So, imagine a woman buys a book. She then hops in her time machine, travels to the past, meets a young man, and gives him that exact book. He thinks it's brilliant, so he copies it word for word and gets it published. Years go by, and eventually that same book ends up right back on the shelf of the store where she bought it in the first place.
Which leads to the impossible question, who wrote it? I mean, think about it. The woman got it from the store, the publisher got it from the man, and the man got it from the woman who traveled back in time. The information in that book is just trapped in a circle with no beginning. It has no author, and that is the paradox.
These paradoxes, they make you wonder if the problem isn't with our technology, but with something more fundamental. Maybe the universe just has rules in place to stop causality from ever being broken. And to figure that out, we have to go back as far as we can possibly go, to the very beginning of time itself.
Now, what's so important to understand here is that the Big Bang wasn't some explosion that happened in space. No, it was the event that created space and time. Before the Big Bang, there was no before. There was no space for it to happen in, and no time for it to happen in.
Stephen Hawking had this perfect way of putting it.
He said asking what came before the Big Bang is just a meaningless question. It's a logical dead end. It's like asking, what's north of the North Pole? You can't go any further north, and you can't go to a time before time existed.
So in the end, this whole quest for time travel really forces us to ask this deep, profound question. Is time like a river that's just carrying us along from a past we can't change to a future we can't know? Or is it more like a giant landscape, a four-dimensional map, where the past and future already exist, and we just need to find a way to get there? Maybe the laws of causality mean we're fundamentally forbidden from ever seeing our own origin. But you can be sure it's a question that scientists, and all of us, will keep asking for a long